Hi friends, my name is Chaitanya Deepthi. I am from Electronics and Communication Department studying at RGKD IIIT Ongole. I have recently completed the Embedded System internship at EMERTXE Information Technologies. I have done the project entitled as Microcontroller Based Washing Machine Simulation using Picsimlab. I am very thankful to the EMERTXE Information Technologies for providing these type of internships for students. Let's start the presentation. And these are the key learnings of my presentation. First, I have divided the presentation into three parts. First, overview of embedded C, embedded systems, and project explanation. Let's start the overview of embedded C. Why is embedded C? It is the most popular programming language for embedded systems because of its efficiency, simplicity, and low-level control. Embedded C has features of C, and it is also close to hardware, portable, and resource utilization predictable, making it ideal for low-level development of operating system kernels and embedded applications. Keywords. The C programming has a total of 32 keywords. Keywords are used for special purpose. They have the predefined meaning in the compiler. These are the list of keywords in the C programming. Number system. C supports binary, decimal, hexadecimal number systems. Data types. The data type will give the information about type of data that the variable store. In a C programming language, the data types are divided into three types. One is basic data types, and second one is derived data types, and third one is user defined data types. Under basic data types, char, int, float, double will come, and user defined data types are structures, unions, and enum, and derived data types are arrays, strings, etc. These are the modifiers and qualifiers. Qualifiers are constant and volatile, and modifiers or size modifiers are there, and sign modifiers are there. Conditional constructs. Control structures are divided into two types: branching, looping. Branching is subdivided into conditional and unconditional. In conditional, if, simple if else, nested if else if ladder will come, and ternary will also come under conditional, and there is a case statements are also there, and unconditional statements are also known as jumping statements: go to, continue, break. Looping statements. The looping statements are used for repeated execution of particular statements until the condition becomes false. Those are while, do while, for. While is known as entry controller loop, and do while is known as exit controller loop. Operators. Symbols that instruct the compiler to perform arithmetic and logical operations on operands. This is the list of operands that the C language supports. Here I have given in order based on their precedence. This is the associativity of the operators, and based on the precedence we have to simplify the expressions. These are the list of operators. Arrays. An array is a collection data of same data type and addresses are sequential. Arrays allows the indexing in C. This is the syntax of declaring an array. We can read the array using loops and store data and copy the arrays into one array into another array, and we can also perform searching and sorting operations on arrays, and we can perform various operations on arrays. Pointers. Pointers enables the C as a low-level language, being a high-level language. By using pointers, we can return more than one value from a function. Pointers store the addresses of another variables. By dereferencing the pointer, by using hash tree, we can access the value at that addresses. This is the syntax for declaring a pointer and assigning address of another variable to the pointer variable. There are different types of pointers such as void, null, etc. Void pointer is points to any data type, but a typecasting must be done. Null pointer it does not points to any location in the memory. Functions. Function has a features of reusability, divide and conquer, and modularity. Reusability. Functions can be stored in library and can be reused many times. When some specific code is to be used more than once at different places. Functions avoids repetition of code. It avoids repetition of writing the code repeatedly. Divide and conquer. A big and a difficult problem can be divided into smaller subproblems and solved using divide and conquer technique. Modularity can be achieved using functions. Code can be easily understandable and modifiable. Functions are easy to debug and test. One can suppress how the task is done inside the function, which is called abstraction. Elements of the function. Whenever we want to write a program using functions, we need to remember the basic components of functions. Those are function declaration, definition, function call. Next, parameter passing techniques. The C supports two methods: pass by value, pass by reference. In pass by value, the formal parameters values are not reflected back into the actual parameters. In pass by reference, the formal parameter values are reflected back into the actual parameters, because in pass by reference we pass the addresses of variables as an arguments. Strings are the sequence of characters enclosed. They allow the indexing. We can perform different operations on strings like string comparison, string reversion, string copying, etc. Storage classes. Storage classes gives the information about variables such as in memory where they will store the data and their scope and their default value, etc. These are the list of storage classes that C language supports. Auto, extern, static, register. Defaultly, whatever the variables we have declared within the main function considered as auto, and these are the storage locations of these storage classes and their initial value and the scope and their lifetime. Extern keyword will be used within the program and outside the program, and it can be accessed outside the files also. And auto static register has a scope within the block only. That's all for the overview of the embedded systems, and let's start the part 2 of this presentation, that is embedded systems. What is an embedded system? A combination of hardware and software which is intended to do a specific task called embedded systems. Example: micro oven, washing machine. When it comes to micro oven, whatever the food item you have put in the micro oven, it will heat the food items. Washing machine is intended to wash the clothes. Categories of embedded systems. These are classified into 4 types: standalone, real-time, network, and mobile. Embedded systems. The standalone embedded systems take decisions on its own, and real-time embedded systems which will complete the task within the deadline. And network embedded systems can connect to other devices and able to transmit data and services. Mobile embedded systems we can carry them from one place to another place. The components of embedded systems. As previously we have discussed that embedded system is a combination of hardware and software which is intended to do a specific task. Here, in order to interface all the components and to the microcontroller, we need to write the code to run a specific task. Actuators are used for physical movement, and sensors will take the input from the environment and process that into the microcontroller. And DAC and ADC are nothing but digital to analog converter and analog to digital converters. In the real world, all the information is in analog, but the computers and microcontrollers will not understand the analog information. They only understand the digital information. So for that purpose, we require digital to analog and analog to digital converters. And here are the human interfaces and diagnostic ports and memory. We require memory to store the code and to access the data from the memory. And we can interface embedded systems with FPGA and ASIC, field programmable gate array, and application specific integrated circuit for a specific task. Generally, the computer architectures are divided into 2 types: One is one human architecture, another one is Harvard architecture. In one human, mainly it has one shared program and data memory, but in Harvard architecture, it has two separate memories where one is meant for program code and another one is for data. These are the general schematic diagrams of architectures of one human and Harvard. Microprocessor versus microcontroller. We need to in a microcontroller we need to externally interface all components, that is timers, memory and IO components. We need to all those components are need to interface externally, so it has more design complexity but more flexible. Example 8086, 8085. When it comes to microcontrollers, components are in a single chip, integrated in a single chip, that is timers, memory, IO ports, etc. So these are less flexible and they have less design complexity because all are fabricated in a single chip. Example PIC microcontroller, Raspberry Pi microcontroller, ARM Cortex, etc. This is the overview of the embedded system, second part of the presentation. Let's start the third part of this presentation, that is nothing but the project. Microcontroller based washing machine simulation using Picsimlab. The problem statement. This project focuses on simulating a washing machine using Picsimlab, aiming to replicate real world washing machine functionality in a virtual environment. Washing machine is one of the main machine in household. Therefore, it is necessary to control the washing machine system to facilitate the user to reduce the time. The project begins with a comprehensive understanding of washing machine components and cycles and their operations. Parameters defining laundry status, such as fabric type, load size, and water level, are identified. Scope. This simulation project will provide valuable insights into the washing machine operations, control system design, and simulation techniques. This project provides practical experience in applying algorithms to simulate intelligent appliances, contributing to a better understanding of laundry automation. These are the project requirements. Based on these requirements, we have implemented the simulation model. First, power on screen. As soon as a board is resetted, press key to power on washing machine. We need to display press key 5 to power on washing machine on CLCD. So whenever we press the switch 5, we need to print power washing machine. The second one is washing program screen. The washing program menu will contain the following washing operations: daily, heavy, delicates, whites, string wash, eco cottons, bed sheets, if we want dry washing only or wash only or aqua store. These are all options available on the washing program, which are displayed on the CLCD. Using the keypad switch 4, we can scroll between the options available. A long press of switch 4 will select the options highlighted with asterisk. Next, water level screen. This screen should allow the user to select water level. The water level menu will contain the following displays: auto, low, medium, high. Using the keypad switch 4, we can scroll between the available options. A long press of switch 4 will select the option highlighted with asterisk. Start screen. Once washing and water level is selected, provide user option to start the machine. If switch 5 is pressed, start the machine, display the function selected and a time taken to complete that work, then switch to function screen. Once machine starts working, display the function ongoing, and it can be wash, rinse or spin, along with display the time left on the CLCD. Completion status screen. Once all programs are completed, display notification as program completed. Remove cloths on CLCD. These are the functional requirements of this project. We need power on whenever we press the switch 5. The system will power on, and whenever we press the switch 6, either it pause or stop washing, and navigation to navigate from one between options, we need to press the switch 4, and the whenever we press the switch 1, it will give the information about door status, and buzzer and motor and displays means CLCD, all are interfaced to the PIC microcontroller. Features of PIC16 F877A microcontroller. It is a 8-bit microcontroller manufactured by Microchip company. It is based on Harvard architecture. It has total of 5 I/O ports: port A, B, C, D, and E. Port A has 6 pins, port B has 8 pins, port C has 8 pins, and port D also have 8 pins, and port E has 3 pins. It has 3 types of memories: program memory, data memory, and data double EEPROM. It supports serial communication, UART, universal asynchronous receive transmit, and I2C and SPI. It has watchdogs and A to D converters and timers, registers and oscillators, etc. The softwares used to implement this project are Picsimlab. In Picsimlab, we have used Pic Genius board. In Pic Genius board, we have selected Pic16 F877A, and X8 compiler. It is a cross compiler, and then cross compiler means we can write the code in one architecture, and we can use it in another architecture. And MPLab IDE, MPLabX IDE. Picsimlab architecture. This is the Picsimlab architecture. This is the PIC microcontroller, and we can interface LEDs, buzzers, digital keypads, and SSDs, matrix keypad, and CLCDs. And we can also interface A to D converters and I2C protocols, etc. And we can also interface memory, etc. Actually, all these are fabricated on a single chip only. Peripherals used to implement this project are LEDs, tactile switch, and CLCD, buzzer and fan, and timers. LEDs. LEDs are simplest device used in most of the embedded applications as feedback. It has a low energy consumption, long life also, small in size. Faster switching make it usable in wide application fields like home lighting, remote controls, surveillance. A port is interface between the controller and external peripheral. A schematic is a document which provides information about the physical connections on the hardware. From the schematic, we come to know that the LEDs are connected to port B and port D. So actually all the ports are I/O ports. So the TRIS registers are used as a data direction register to configure the I/O ports. So whenever the TRIS B or TRIS D is assigned a value 1, then the ports corresponding port B or port D act as a input ports. If we assign 0, they act as a output ports. CLCD, character liquid crystal display. It is most commonly used to display ASCII characters. Communication modes are 8-bit mode and 4-bit mode. This is the CLCD architecture in PIC microcontroller. Tactile switch. Tactile switches are also known as digital keypads, used to start and stop equipment and to set and change operating conditions. Provides a simple and cheap interface. Some common applications of tactile keys are HMI, mobile phones, computer, mouse, etc. Actually, in this project, we have used tactile switches to navigate between the options, and to power on the washing machine, we must press switch. So in that case, we have used tactile switches, and this is the schematic diagram of tactile switches in the PIC microcontroller. Timers. Timers plays important role in any application of embedded systems, which is a default peripheral in. It maintains the timing of operation, is synced with the system clock or an external clock. It has many applications such as measuring time and generating delays, etc. Buzzers. It is a device that makes a buzzing sound like electric bell. These are used to indicate completion of some task or work, or to indicate any problem in the system by making sound in embedded systems. the in our project, we have used buzzers when the washing machine starts working. Whenever the washing machine completes its program, the buzzer sound will be stopped. Fans are one of the most cost efficient option for system cooling. Here also in this project, we have used buzzers and fans from the starting of the machine working to ending of the whenever the washing programs will completed, the buzzer sound and fans will be stopped. Interrupts. An interrupt is a communication process set up in a microprocessor or microcontroller in which an internal or external device requests the MPU to stop the processing. The MPU acknowledges the request, attends to the request, goes back to the processing where it was interrupted. Whenever there is an immediate access access from external device to MPU. H file we have defined some macros, and the level detection and water level and state detection, in which state the washing machine will is running, and keypad ports are defined and input lines are defined, and here we define the switches. Whenever we press the switches, the value they navigated to that particular switch. Here we also all released input lines, and we have defined read digital keypad. To read the digital keypad, we have defined some functions, and init digital keypad also used. This is the CLCDH file. In this also we have defined some macros related to the display. This is the CLCD data port and CLCD enable, inst mode and data mode, and CLCD lines. And CLCD has a pins, so those pins are defined here: line 1, line 2, line 3 and line 4. And we have also you defined in this actually we have discussed that 4 pin and 8 pin modes are there available in CLCD. So here we have defined 8-bit mode, 8-bit data mode, and display screen, and we have defined all these macros, and we have also declared some functions, CLCD print functions, and here we have declared a clear screen. And this is the header files of the timers. We have defined timer 0 and timer 2, but in this program we have used timer 2. This is the main header files and main H. Here we have defined washing program display and water level for the program, and start or stop the screen, and start program. These are all macros. And here we have defined washing program display reset, water level reset, start program reset, rest. nothing. And we have also defined the peripherals, fan, buzzer, and fan DDR, and on off. And we have here defined the functions: power on screen, clear screen, and washing program display functions. And what for water level, we have defined the water level display function, and to set the time for the completion of some washing program, we have defined set time for program and run program. And to know the door status, we have also defined the door status function. This is the C file for digital keypad. Here we have included the digital keypad header files. It our keypad port, the crispy is pressed, then it navigates to the corresponding action. Keypad and long whenever we mode level based on the mode we have selected, the task will be performed. And this is for long press. We have told that whenever we press switch 5 or switch 4, it will print some output on the CLCD screen, and the corresponding it also shows the function we need to we require to perform. These are all the time code for digital keypad. And timers, I already mentioned that timer 2 is used in this project, and we are going to define some PR and loading preload registers, and interrupt is enabled, and switching. Here we have switching on the timer. This is the interrupt control code. And here we have whenever there is an we need before ISR we have defined the function called interrupt. And whenever the timer 2f is equal to, we have count the number of times it is over. These are the function for timers interrupt handling. And this is the program for CLCD file. Delays, etc. This is the all code for the CLCD screen. This is the main function. Here all the header files are included in this main file. Here we have configured WDT off, and here we initialize all the peripherals, digital keypad and timers and buzzers and fans equal to 0 initially. We have initialized all those parameters with initial values. And initializing operation modes, washing programs. Here we have declared a reset mode, program number equal to 0, water level index. And washing program will contain daily, heavy, delicates, whites, strain wash, eco cottons, etc. And water level options, we have used auto, low, medium, high, max. And here we have defined some variables. And we also declared variables for wash time, rinse time, and spin time. And this is the operation mode, washing program display and washing program display reset. Whenever we press the key 5, the CLCD will print press key 5 to power on washing machine. So this is related to the washing machine power on screen program. And to read the digital keypad, here we have digital keypad state, we have read the program. And every washing program, whether it is spinning or rinse or wash, here we have write the code for display required message, press the switch. Here we have mentioned that to start the washing program we need to press the switch 5. If we want to stop the washing machine, we need to press the switch 6, which is these are also displayed on the CLCD screen. And then washing program display. These are rated for water level and start stop screen, and all these are mentioned here. And power on screen. To power on the screen, we have read the code for that. When for the CLCD will print powering on washing machine. Whenever we have pressed switch 5, the CLCD will print powering on washing machine. Washing program display. These are based on the switch we have pressed, and it navigate to the particular function. These are all written for washing program. And this is the code for water level display. Here we have set a time for each and every for spinning and rinsing and washing of clothes. And water level index also we have right up for daily for daily clothes washing we have set time some time. If they are heavy cloths, then we have set some time for cloth washing. And based on the fabric or based on the type of cloths which we wear, according to that the washing machine will take the time to wash the cloths. This is the code for door open check. Whenever the door is opened, the fan and buzzer will be offed. When the washing machine starts its programming, then only the buzzer and fan will on. The fan is used to cool down the washing machine. The CLCD will print in the door status as a door open, please close. Whether the door is opened or closed is mentioned in the CLCD. For starting the washing program and stopping, these are also mentioned here. So run program. These are also for running the program during the washing machine runs their program. This is all are mentioned here. And the whenever the washing machine starts it functioning, it will the CLCD will display the how much time left for left to complete the task. Wash time is these are calculations for wash time, rinse time and spin time. And whenever once the time is completed and once the time is the washing program is also completed, then the CLCD will display the program is completed. Remove the cloths, and operation mode is washing program display. These are also displayed in washing program display. And this is the code for washing machine automation using Picsimlab. So we have written all the codes for digital keypads, timers, and interrupt handling and CLCDs, etc. So these are all need to be run using By clicking on clean and build, we have run all these programs executed well or not. This is the PIC16 FA777A simulator board. To run this board, here we need to load the hex file. This is the hex file which I want to load into the Picsimlab. The display shows that press key 5 to power on washing machine. This is the CLCD display of 16x2 or 16x4. There are two modes available. These are the switches, and this is a switch 1, switch 2, switch 3, switch 4, switch 5, switch 6. These are all known as digital keypads, and this is the buzzer, and this is the fan. And in order here it shows the press key 5, so I have clicked on the press key 5. It shows powering on washing machine, and then it shows washing programs. When I press on switch 4, it shows washing programs, daily, heavy, delicates. If I continuously pressing switch 4, then it will this must show that whatever the level I want to require. Here I have, after that it shows water level. After selecting washing program, it shows water level. Here I want to the water levels are auto, low, medium, etc. So here I want to continuously pressing on switch 4 and select low as a water level. So hence if I press the switch 5, then it will shows the press switch 5 to start and press switch 6 to stop. So here I press the switch 5 to start the program. So the function starts, and it shows the washing program as wash, and time elapsed for completing the washing program. Here 5 is switch 5 denotes to start, to press the switch 6 to pause the program. And so I have pressed switch 6 to stop the program. Here the fan is also stopped, so that means the function is on rinse, and time elapsed left 15 seconds. So if I press the switch 5, then the function starts again. Then it shows the function is spins, washing machine spinning the cloths. So the time, whenever the time elapsed reduces in seconds. Whenever the time reaches to the 0, then the program ended. It shows program ended, remove cloths. This is the program we have run. Finally, these are the simulation results. First, power on screen, powering on screen, washing program screen, water level screen, and start screen, function screen, door status screen, program completion status. Conclusion: the washing machine simulation using Picsimlab observed as an effective tool for learning and applying concepts in embedded systems. It offered a hands-on experience that complemented theoretical knowledge and provided a foundation for further exploration in the field of automation and control system. Thanks to EMERTXE. EMERTXE have provided the internship which at free of cost for the students, and it is very beneficial for me. I gained the practical hands-on experience on simulation tools, and as well as PIC microcontroller as well. Thanks to EMERTXE for providing me this opportunity. Thank you all.